All right, this is College Algebra, Northern Oklahoma College, Math 1513. I'm doing Chapter 1, Section 5, and we're going to be solving inequalities using the critical value method. All right, let's cover a little background before we get started. I want you to think back to examples 17 and 21 when we talked about that, and the absolute value of 2x minus 9 is less than 7, and we came up with this graph and this solution. Okay. What's coming is the 1 and the 8 we're getting ready to call critical values. So we will do our work, we'll solve the equation, and we'll come up with x equals 8 and x equals 1, for example. On the number line, it would look like a 1 here and an 8 here. And if you'll notice, this breaks our number line into 3 segments. We have this segment here that goes out to infinity. We have this segment here in between the 1 and the 8, and we have this segment here on the right that goes to the right out to infinity. So we have 3 distinct separate segments. The question that we're asking ourselves is, where are my solutions? Are they in this left segment? Do those points work? Are they in between the 2 numbers? Do those points work? Are they that segment right there heading to the right? Is it those points that work? So we have to check each segment and find out which points in which segments work. So we're asking ourselves 3 questions. We're saying, do the points in this left segment work? Do the points in the middle segment work? And do the points in the right segment work? All right, the way we're going to find out which points work is we're going to test a point in each section. Now, which points do you pick? It doesn't matter as long as the point that you pick is in that segment, that section. So if I was looking for a point to test in this first section, you can pick any point in there. I'm going to test x equals 0. Why do I pick 0? Well, first of all, it's in the segment. And second of all, 0 is a real easy number to work with in calculations. If I was going to pick something in the middle segment right here to check, well, it can be anything. I could check x equals 3, or x equals 4, or x equals 5. I can pick any number in that segment to test. And finally, if I was going to test something out here, I would probably pick 10, because 10 is easy to work with in calculations. But you could pick any number. You could pick 11, you could pick 100, you can pick whatever number you want as long as it's in that segment. Now, what do we do with those numbers we pick? We plug them back into the original equation and see if they work. We see if they are solutions. All right, so that's what's coming. We're getting ready to work some assignment problems now, and that's what's coming. We're going to find the critical values. We're going to find the 2 numbers we're talking about, which splits the number line into 3 sections. And then we're just going to test a number in each section and see which sections work, which numbers in which sections work. All right, let's start with an example for number 29. X squared minus 49 is less than 0. Now, what I want you to do to start off with is just pretend this is an equal sign just for a minute. Pretend it's an equal sign just for a minute so that we can solve this and find the critical values. All right, so we have x squared minus 49 is greater than 0. We're going to pretend that it says equals 0, and we're going to go ahead and solve that equation to find our critical values. Now, hopefully by now you guys recognize this special pattern here. We can rewrite 49 as 7 squared, which gives us a square minus a square, which breaks down into that special pattern, x minus 7x plus 7. Once we get to this point, we set each one equal to 0, which gives us x minus 7 equals 0 and x plus 7 equals 0. We solve both of these. And what do we have here? We have our critical values. right here and here. Okay, at this point it always helps to make a visual. You don't have to make a graph, but it sure helps me, so I recommend you do it. Put your 2 slashes on there, which splits your number line into 3 segments. We're talking about -7 and 7. Of course, -7 goes on the left because it's lower. So our question is, do these points work? Do these points work? Do these points work? We got to find which points work, which segments work. So I have to decide which numbers I'm going to test. All right, I had to make my number line a little bigger because I need room to work. All right, for my first section here, I need to pick a number in there to test. I'm going to test -10. Why -10? Just because 10s are usually easy to plug into calculations and work out. For my second segment, my middle segment, I need to pick a number in there to work with, and I try and think of the easiest number to work with. Well, 0 is always easy to plug into calculations. And for my third segment, I need to pick a number out there that's easy to work with, and I'm going to pick 10 because 10s are easy to plug into equations. Okay, so I've decided the 3 numbers that I'm going to test, and I go back and I write the original equation. I'm going to plug those numbers back into the original, well, not equation, inequality. I'm going to plug those numbers back into the original inequality and see which numbers work and which numbers don't. All right, the first thing I recommend before you start plugging numbers in is I highly recommend you put parentheses around your variable before you put the number in, especially with negative numbers here. When you plug negative numbers in for x's, that negative, when you square it, tends to cause trouble if you don't use parentheses. All right, so I'm going to take out the x and plug in -10. In the middle, I'm going to take out the x and plug in a 0. And on the right, I'm going to take out the x and plug in a 10. And now we just do a little math. On the left, I get 100 minus 49 is greater than 0. So 51 is greater than 0. And you know what? That's true. That means there are solutions on that left section. In the middle, I get 0 minus 49 is greater than 0, which means -49 is greater than 0. And that is false. That's not true. So that means I don't have any numbers that'll work in the middle section. And on the right, I have 100 minus 49 is greater than 0, which means that 51 is greater than 0, which again is a true situation. So what I've found, what this means is there are solutions on the left segment. All the numbers on the left segment will work. There are no solutions in the middle segment. Nothing in the middle segment will work in our inequality. And there are some more solutions on the right segment. So our left and right segment hold all of our solutions. All right, and there's what we've come up with. On the left, yes, it's true. There are solutions in this section. In the middle, false. No, there are not any solutions in this section. And on the right, true. Yes, there are solutions in this section. So let's get a visual of where our solutions lie. All right, so our original inequality was x squared minus 49 is greater than 0. You guys know I like to have a visual to see what I'm talking about. We decided that our critical values were -7 and +7. And we decided that we had solutions on this left segment. And we had solutions on the right segment. Now, what about the numbers themselves, the critical values themselves? Well, notice that there's no equal sign, so the numbers themselves are not included. So we could put an empty circle like that if we want to use the junior high method, or we could use the parentheses to show they're not included, as the book does. Now, for our final answer, we have to write it in interval notation. Well, let's look at this left interval right here. How do I express that interval going from left to right? Well, on the left, it's going out to -infinity, comma, and on the right, it goes to -7. So I'm talking about the interval from -infinity to the number -7. Is -7 included? No, it's not, so we use parentheses. You can't include infinity because we can't really define it, so it's not included. What about the interval on the right? Well, I'm talking about from the -7 out to positive infinity. 7's not included, positive infinity is not included, and we want these two sets to be linked together, so we put the union symbol in between them. And there's our final answer. All right, here's an example for your problem number 33. X squared plus 5x plus 6 is less than 0. I want to know where the solutions are, and I want to write the answer using interval notation. Remember, we're going to pretend that's an equal sign, and we're going to factor. And you guys know how to factor by now, so we have +2 plus 3 equals 0. So we have x plus 2 equals 0, or x plus 3 equals 0. We solve each of these and get x equals -2 and x equals -3. And remember, these are called our critical values. Now let's get a visual of what we're talking about. Here's my number line. I'm going to put -3 here because, of course, -3 is lower than -2. And we have 3 intervals to test. I want to test a number in that interval, and I want to test a number in that interval, and I want to test a number in that interval. All right, I need a number somewhere in this interval, and I'm going to choose the number 0. Whoops, I can't choose 0. 0's not in that interval. Let's try again. What am I going to choose? I'm going to choose -10. Okay, -10 is in that interval. Why did I choose -10? Because it's easy to calculate. You could have used -4, -5, -6. You can use any number in that interval. What about this middle interval? What's the easiest number I can choose? Well, there isn't really an easy number in there. What's in between -2 and -3? Just decimal numbers. I'm going to choose -2.5. That's not easy to calculate, but that's what we're stuck with. And on the right interval, I'm going to choose the easiest number I can think of. And there I'm going to choose 0, because 0 is in the interval, and 0 is easy to calculate. Okay, next I put my original inequality back up there, and I'm going to test each number in the inequality. Again, I can't say this often enough. Put parentheses around your x, especially when you're dealing with negative numbers, because negative numbers will mess up your calculations if you don't handle them properly in your calculator. All right, there are my substitutions. I took out the x's and put in my test values. If you put this in your calculator, you get 56 is less than 0. Ask yourself, is 56 less than 0? No. So you can write no or false. And I put the middle calculations in my calculator, and I get -0.25 is less than 0. And ask yourself, is -0.25 less than 0? Well, any negative number is, of course, less than 0, so that's true. And finally, I put calculations in my calculator, and I get 6 is less than 0. I ask myself, is that true? No, that's not true. That's false. And so now I know where my solutions are. My solutions are going to be in that middle section right there. All right, so I'm looking at my visual. I have all the numbers between -2 and -3. What about the numbers themselves? Remember, there's no equal sign here, so these numbers are not included. So I'm going to use a parentheses to show that. Okay, the graph wasn't required, but that's a good visual. So now let's write our answer in interval notation. What are we going from? We are going from -3 over to -2. Are the numbers themselves included? No, they're not. So we use parentheses. All right, here's a quick little hint on how to do your number 55 word problem. I'm just going to kind of break up our question into 3 parts. So you're asking yourself, when is the low charge less expensive than the fee saver charge? Well, translating that, the low charge is $5 plus a penny per check, and it needs to be less than the fee saver, which is $1 plus 8 cents per check. So you could say it's 5 plus 0.01, that's a penny, times the number of checks written, which we'll call X. So look at that and see if you can take it from there.